Alright, some more examples for us. Oh joy, oh rapture. We've got f of x is x squared minus 4, and we've got g of x is root x. Now this guy is a fussy, so look out for trouble. If he gets into stage 2, we could have a little bit of trouble. So, for both f of g of x and for g of f of x, what do we have to do? Firstly, we have to verify whether the composite function is defined. And secondly, if not, modify the domain so that it is defined. And thirdly, we have to sketch the graph of the composite function. Wow! So this should really help us to understand how these things work, okay? That's the purpose of the question. Let's deal with g of f of x first, okay? So that's going to be the square root of x squared minus 4. But first of all, I'm getting ahead of myself. Let's do the old assembly line diagram. So here is stage 1, which is x squared minus 4, and let's have a look at that. What would be the domain of that? Well, it would just be any old thing, so it's R, yeah? And the range of it would be, if you look at the y-axis of my little graph up here, would be from minus 4 up to plus infinity, okay? So I've written that there for you. Now let's check out the stage 2, which is g, which is root x, okay? That is stage 2 in this two-stage assembly line process. And we've got a little graph of it up here, as you can see. You can see that this guy can only accept 0 up, including the 0, yeah, for his domain, and of course his range is the same thing. So you can see here, guys, we've got a problem. We've definitely got a problem because this range is not wholly contained within this domain. So we've got to do some surgery, okay? So what have I written there? I've written, yes, that's what I wrote. The range of f is not wholly contained within the domain of g. So we've got a definite problem. Can you see that with that number line? The number line is a really great way of unraveling your thoughts on this. You see, there is the range of f going from minus 4 up, including the minus 4. There's the domain of g from 0 up, including the 0. So you can see there's a bit of this red line which is outside the green line. So this is no good. Yes, that's the problem, that area there. So we know that GOF is not defined in its present form. So now the task for us now is to modify the domain so that it is defined, okay? So we need to restrict the domain of f so that the range of f is from 0 up, including the 0, don't we? Yeah? Okay, so how do we do that? Well, if it's a quadratic like this one is, I always recommend draw the quadratic and then have a look closely at the graph. You want the y values of this graph to be from 0 up. So in other words, you want the parts of the graph which are on or above the x-axis, don't you? Alright, so that's what we want, okay? And to work out what x values produce that part of the graph, what we do is we first of all find the x-intercepts, which I've just done there very simply for you. Then you draw this curtain of vertical lines from the parts of the graph that you want down to the x-axis, pointing to the x values which give rise to these heavily green shaded parts of the curve that we actually want, okay? See, it's pretty easy, isn't it? Now you can see what x values we want. We want from minus infinity up to and including minus 2, or we could have 2 including the 2 upwards to plus infinity. See? It's just a piece of cake, isn't it? When you draw a diagram, you can understand what to do very easily. So here's our modified and restricted domain version of GOF. Yep, we've got from minus infinity to minus 2 including minus 2, combined with the plus 2 up to infinity, including the plus 2. Now, this now only produces this, which is exactly what we want because it coincides with that domain of stage 2, the fussy, yes? And, of course, the range that gets produced from stage 2 with the domain of that is this one here. So now everything's good, you see? Everything's good. And that's the domain of GOF, or restricted GOF now, this one, and this is the range of restricted GOF, yeah? Happy? So let's go over the screen now and do part C. We've got to sketch the graph of the composite function as now defined, okay? So we know that a GOF is g of f of x, which means it's the square root of not x but of f of x being x squared minus 4, and this is our new domain, yeah? So what we've got to do is we've got to sketch that, which is not something very familiar to us. So I suggest you go straight for the CAS and just do it that way. So that's what I did, you can see. So it's very unfamiliar, but this all makes sense, you see. Look, here is minus 2 and 0, this coordinate point here, and here's plus 2 and 0, and you can see that we want this bit here from minus infinity x up to x is minus 2, and this corresponding bit here where x goes from 2 up. There it all is laid out for you. You can see that that's our answer to the whole thing, yeah? That's the domain, that's the range, and let's go on. Now we're going to do fog now, okay? We just did GOF, we're going to do fog. Same thing for fog, right? So let's look at that. This is now stage 1, which is root x. You see the little graph of it. What would be the domain and range of that? That would be the domain, that would be the range, and similarly for stage 2, this would be the domain of that quadratic, and the range, of course, would be from minus 4 up. Now, let's have a look at the middle to see, oh yes, we've got no compatibility problems there at all. See, 0 to infinity certainly fits wholly within R, doesn't it? So the range of G is wholly contained within the domain of F, so therefore the whole thing is defined, no problem. So therefore the domain of fog is the left-hand side bit, which is 0 to infinity including the 0. It's the domain of G in fact, but it's also the domain of fog. And the range of fog is this right-hand side here. Yep, minus 4 up. That's really good, isn't it? Okay, let's work out what the equation is. F of g of x is in fact g of x squared minus 4 instead of x squared minus 4 because it's f of g of x. And we know that the domain is from 0 to infinity including the 0. So that comes out to be just g of x squared, which is root of x squared, which is just x minus 4. But this is the kicker. This is the kicker. X goes from 0 up, okay? Only from 0 up. There is the graph of it, you see? X minus 4 from x is 0 up.